Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through the 12A group work. We'll probably also go through the extra practice or extra review, whatever you want to call it. And then yeah, let's start solving some of this stuff. So you got to show all your work, got to do all these things without a calculator because your test will be no calculator. So the idea behind matrices is it's systems of equations or systems or numerical values represented all at once. Think about it as a number that's really like a bunch of numbers at once. That's like a matrix. Um, but like for you to have matrix equality, like this question in number one, that means that each of the individual terms need to be equal to each other. Like notice you have an 8 here and an 8 here, they're the same, and a 58 here and a 58 here. Well, that means that all of the places where they're like in the same location, those values are going to be the same. Like for example, this -3 is the same as this x minus 7. So what I would do to solve a problem like this is I would look for an equation that has just one variable and it's equal to one number. That's like the easiest way to work through it. So like I'd see this and -3, and since those numbers are supposed to be the same, it would just become an equation. -3 is equal to x minus 7. Then I can solve for x really easily, right? All you got to do is just like add 7 to both sides. So x is equal to 4. So that gives you all of the x's. So you can start, plugging all those numbers in if you want. So like, for example, this guy right here, -5. So -5 times 4 tells me that number is really -20. And that 7 times x is really like, 28. You just start like plugging all the stuff in if you want. 4 times 2, that's really 8. So that's an 8 right there. And that's a 4, and so on. So we really only just have like, one variable that's left because, we can now solve for any y's. So really all you got to do is just pick like one equation that has a y in it. I don't know, just arbitrarily I'll pick like the first one, first entry in there. So it'll be the following equation. I've got 8 plus 5 is equal to 19 minus y. I kind of did this quickly, so I want you to kind of notice what I did here. It started off as 2x plus 5, but I turned in 4. I plugged in 4 for x. So 2 times 4 is 8. So that's why that became like an 8. And, obviously 8 plus 5 gives me 13. So I can just rewrite that as 13. And then if I subtract 19 from both sides, I get -6 is equal to -y. And therefore y is going to be equal to 6. So I've got like, all my values on there. And you can like plug in, make sure that everything makes sense too. Like, if I plug in 6 over here, 6 minus 4, that should be 2. It's 2. And then 28 minus 8 times 6, that'd be 48. So 28 minus 48 is -20. That's correct also. So you can like double check all that stuff once you solve for your variables. But the key is just like to take one of the places that have variables and then set it equal to the other corresponding part. Okay, so there you go. That's about as easy as it gets. You could have done this differently, I guess, and still get the same results. You could just pick anything that has the variables in it. Like, I could even take these two, even though I still have two variables, 2x plus 5 equals 19 minus y. And, I could take this one also, I guess, whatever, or this one, 2 and y minus x. I could set those equal to each other. And I could, just solve for one of the variables. Like maybe I'd pick this equation here and solve for y. So y is equal to 2 plus x, right? And then I can use substitution. So wherever I see a y, like right there, I can plug in 2 plus x and solve. See, watch. So I get 2x plus 5 equals 19 minus, the y value, which is 2 plus x. And remember what x was? X is equal to 4. That's what I should end up with. And I'll show you that's what I'm going to get. 2x plus 5 equals 19. And then that'd be minus 2. And then minus x. 19 minus 2, that's 17. And then if I were to add x to both sides, I'd get 3x. And then if I were to subtract 5 from both sides, I'd get 12. And see, I get x equals 4 again. And I can start the process anew. I can, solve for y again. And y will be 6. Either way I want to do it. But, like, how did I do all this stuff? I just took the corresponding parts and set them equal to each other. That's what you got to do for this, okay? All right. Next up, number 2. So perform the following operations, if possible, I guess. Not all of them are going to be possible. Because if you have to do matrix multiplication, you need to make sure that the following is true. So whatever the if I want to multiply A times B, I have to make sure that what we call the inner dimensions of the matrix are the same number. So matrix A, like I'd want to find its dimensions n by n, okay? And for these two matrices to multiply, I know that the matrix B has to have n as its first inner dimension. So the way that I find the dimensions is the following. Like the first number is going to be the number of rows on the matrix, and then the second number is going to be the number of columns. And that's the same for both of these, okay? So that's like rows and columns, okay? So for each of these. So I need to make sure that inner number is the same. So if I want to multiply A times B, so I'd like write them up, 2, 0, 1, 1, 3, 1, 4, negative 1, negative 2. And I want to multiply that by the matrix B, 1, 2, negative 1, negative 1, 0, 3, 3, 4, negative 1. Then I need to make sure their inner dimensions are the same. So like the matrix A is a 3-row by 3-column matrix. And the matrix B is also a 3-row by 3-column matrix. So as long as these numbers are the same, they will be able to multiply together. And another cool thing is that the product of the two of them, so when you multiply them together, the dimensions on the outside will give you the resulting matrix, so the product. So I'm going to end up with a 3 by 3 matrix, so 3 rows and 3 columns. So let's start doing some of the work. So here's what I like to do to organize my multiplication. The left matrix, I break it up into rows like this, and then the right matrix, I break it up in terms of columns, so the up and down parts. And what I do is something called the dot product of the rows and the columns. So what you do is you just go in order. So like if I want to do the first row, right? So I'm going to have, it's going to be a 3 by 3 matrix, right? I've determined that from 3 by 3. So I'm going to have 3 rows and 3 columns. So I'm going to write out all my different stuff over here. So 3 rows and 3 columns. Okay. And then what I'm going to do is multiply this stuff together. And here's how it goes. Ready? So I do one row at a time. So I go, first row. I multiply that by the first column, this one. And that's going to give me the first row, first column right here. So row 1, column 1. All right. So here's what I do. I multiply the individual parts together. So 2 times 1. And then 1 times 1, negative 1, I'm sorry. So 1 times negative 1. And then 4 times 3. And then I add them up. That's going to give me like that number, okay? And here's how it's going to look. It's going to be a 3 by 3 matrix. And let's find that first entry in my matrix. So that would be 2 minus 1 plus 12. Well, 2 and 12 gives me 14, and 14 minus 1 is 13. So 13 would be the first number that I get in this multiplication procedure. Okay, and then the next one I'm going to do is find this guy right over here. This is row 1, column 2. Okay, so I do row number 1 times column number 2. All right, I'm going to do the same procedure. So I take like the 2 and multiply by the 2. And then I take the 1 and I multiply by the 0. And then I take the 4 and I multiply it by the 4 over here. Okay, and then I add those numbers together. And that's going to be the next entry that I get. So that's going to be 4 plus 0 plus 16. So that's a total of 20. So 20 is going to be the second number that I get in my row. And this takes a little bit of time, but it's not that bad. Honestly, it's just tedious. Okay, so the next thing I'm going to do is row number 1 and then column number 3. That's this entry right over here. Row number 1 because it's on the top row, and then column number 3 because it's farthest on the right. So what I do is I take row number 1 again of the left matrix and multiply it by column number 3. Okay, so I do 2 times, this number here, -1. And then I do 1 times 3. So 1 times 3. And then I do 4 times -1. So 4 times -1. And then I multiply them together and then add. So that'd be -2 plus 3 and then -4. So that's going to be a -6 plus 3. So that'd be -3 for this number over here. And I just keep doing this procedure. Here's the cool thing. Like if you organize it like what I did, I kept everything kind of consistent. Notice that like for the top row, right, I'm going to use all these row numbers, okay? And, I always put them like on the outside of the parentheses like this. So that's going to stay like consistent. See, they're all the same thing, right? Same order, same pattern. And then, so every time that you use a new row, you just stick it at the same location. So like, see, I have 0, 3, and -1. Well, I'm going to do the same thing, 0, and then 3, and then -1. And then it's going to be the same thing here, 0, 3, -1, and 0, 3, and -1. All right. And so watch this, okay? So I just did that, and that's like where the rows are going to multiply, just like what I did with the little arrows there. It's like that's where the row goes. See, 2, 1, 4, 2, 1, 4, right? And then check this out. This is like the other cool part about it. The other numbers that you have, so these guys, these are all going to be the columns. These numbers that I just put arrows on, 1 and -1 and 3, those just like migrate down here. So 1, -1, and 3. So I can like do that again if I wanted to. 1, -1, and 3. And so, like next up will be the 2 and the 0 and the 4. So that's going to go here again, 2, 0, and 4. And then I've got -1, 3, and -1. And that goes down here again, -1, and then 3, and -1. It just migrates down. All right, now I've got my last row. So that's the last part that I need to plug in before I just start doing some like algebra. So the last row is 1, 1, and -2. So those go on the outside, 1, and 1, and -2. Plus there, and then 1, and 1, and -2. And then 1, and 1, and -2. See, it's just like a big old pattern, okay? And now it's just simple algebra from here. So, you can fast forward if you want, but I'm just going to get the next couple rows. So 0, -3, and then -3 again. So that'd be like -6. And then 0, and 0, and -4. So that'd be -4. And then 0, and 9, and 1. 9 and 1 is 10. All right, and then we've got 1 and -1, which is 0, and then -6 is -6. And then we've got 2, 0, and -8. 2 minus 8 is -6. And then -1 and 3 is 2. And then 2 plus 2 is 4. So there we go. That's what happens when we multiply those two together. All right, so there you go. There's the first multiplication done. A little time consuming, right? So do you think that you're going to get like 10 of these on, on the test? Heck no. It's just going to be like one multiplication if it's a 3 by 3. If you got 2 by 2, it's a lot easier to multiply. All right, so there you go. Just make sure it's the rows of the left times the columns on the right. That's how you do the algorithm for multiplication. And as I erase this, I'll also give myself a little bit of an endorsement for linear algebra. So if you're right now in your freshman year of Honors Algebra 2, or your sophomore year, you can make it to linear algebra, my class that I teach for like seniors and some juniors. and it goes over matrices. So specifically these things, and it makes things really, really easy. So like, you know, it took a while to get multiplication for just like 2 matrices. I'll show you guys a way to find them really, really easily, and then also unlock a lot of potential in matrices in general. All right. Well, that's enough for this video. I'll make a next one, and then that'll be it. So I'll see you on the next video. Bye-bye.